Assalamualaikum and hi class. In this video, I will explain to you about the mechanism of electrophilic aromatic substitution in benzene. We will start with the first reaction, which is halogenation. Before we go to the mechanism, this is the general steps in the electrophilic aromatic substitution. The first one is the formation of electrophile. The second one is formation of Arinium Ion. The third one is loss of H+. Alright, now look at this example. We have benzene plus halogen or bromine with the presence of FeBr3. FeBr3 here is as Lewis acid or catalyst. The function of FeBr3 or Lewis acid in the electrophilic aromatic substitution is to increase the polarity of the halogen so that it can produce the electrophile in the reaction. Alright, so for this reaction, we will get bromobenzene plus HBr as our side product. Now we will start with first step, formation of electrophile. Or in this reaction, the electrophile involved is the complex ion. Let's look at how is a complex ion. First, our halogen, bromine molecule, it will react with the Lewis acid FeBr3. So, look at the arrow. The lone pair from bromine will attack the Fe of FeBr3. So, we will get this complex ion. This one we call as complex ion. Br, and it attached to FeBr3. Now, this atom of bromine will become positively charged. This one will become the negatively charged. This positively charged make the ion as the electrophile so that it can react with the benzene, which act as nucleophile. Now we go to second step. It is formation of Arinium Ion. Arinium Ion is the benzene as a positive charge. Okay, in the second step, benzene, it will react with the electrophile here, which is a complex ion. So remember, the arrow must be from electron rich to electron poor, and in this case, the arrow must be from this CC double bond of benzene, electron rich. It will attack one of the bromine here, which make this Br bond break, and 2 electron will go to this bromine. So what we will get here is this bromine will attach to one of the carbon of benzene. In this case, I choose this carbon. So this carbon, it has hydrogen and Br attached to this carbon. So now, when Br attached to this carbon, the CC double bond break. CC double bond of benzene will break, and which make the carbon at the other side become positively charged. So this actually is an Arinium ion. But class, remember, benzene, it has pi electron that can be delocalized. The electron at this side, it can move to this side, or it can localize to this side, which it will produce another structure, CC double bond here, and this carbon has become the Arinium ion. The same thing happen at this side. So these 2 electrons will move or will delocalize into this side, and we will have another structure, which is CC double bond here and positive charge here at this carbon. So all of these 3 structure, we call it as resonance structure. So in the mechanism, you have to show all these 3 resonance structures. Okay, now we go to step 3, loss of hydronium ion. So you choose one of the Arinium ion. Let's say I take this structure, and I will draw back in the step 3. In step 3, the FeBr4 minus that formed from previous step will involve in this step. So now we want to remove H plus from the neighboring carbon of the Arinium ion. So this hydrogen will be removed. Okay, so what happened here is the lone pair of from FeBr4 minus, it will attack the H atom and it will make the CH bond here break, and 2 electron will go to this side so that you can get back your double bond in the benzene ring. So let's look at the product. Now we already get our double bond for benzene ring, and we have get the product which is bromobenzene. And when this bromine attach Br, this bond will also break. This FeBr bond will also break. So we will have another product which is HBr, and also we get back the Lewis acid FeBr3. So this is the mechanism of halogenation of benzene.